Alright guys, welcome back. So in this video we are being solving some mechanics problems. So first one is pretty easy. So before solving the problem, give it a try guys and check out the solution. So the first problem says a projectile of mass is traveling at a constant velocity toward a stationary disk of mass and radius that is free to rotate its axis. Before impact, the projectile is traveling along a line displaced a distance below the axis. The projectile strikes the disk and sticks to the point. Model the projectile as a point mass. So the first part is before impact, what is the total angular momentum of the disk projectile system? About the axis, answer the following question in terms of symbols given at the start of the problem. So the first part is pretty easy. So total angular momentum before the impact is mp v naught b. So v naught is the initial velocity of the projectile. So b is the distance from axis. So first part is easy. So second part, what is the angular speed of the disk projectile system just after the impact? So basically in the second part, we conserve the angular momentum about the axis. Okay. So L initial equal to L final. Initial angular momentum is mp v naught b equals total moment of inertia about the axis m r square by 2 plus mp r square into omega. So final angular momentum is so 2 mp v naught b by m plus 2 mp into r square. Okay. So the third part is what is the kinetic energy of the disk projectile system after impact. All right. So after impact, it just rotating, not translating. So we just write half I omega square. In the place of I, we substitute moment of inertia. Omega we got here. So just substitute here. All right. So the fourth part of the question says how much mechanical energy lost in the collision. So guys, just comment on the answer of the fourth part. So if you get any doubt, I will do in the next video. All right. So in the second question, so basically I took this problem from Pathfinder NLM chapter. So in this question, in a gravity free place, a long cylinder of radius 30 centimeters wears a thin uniform ring that can slide on the cylinder. When the ring is given an angular velocity omega equal to 10 radians per second, it stops in t naught equal to 3 seconds. Now the ring is given the same angular velocity and simultaneously projected along the rod with speed u equal to 4 meter per second. How far will the ring move along the rod before it stops? So basically the question says, firstly, it is given only angular velocity, so it rotates. Afterwards, it translates with the velocity u along the axis of the cylinder. Alright, so first we analyze the initial condition. Alright, so it has velocity v equal to r omega along the tangential direction, and friction opposes the relative motion opposite to it. So from first condition F equal to ma, from this we get acceleration equal to friction by mass, mu into n by mass. Alright, so using the equation of motion v equal to u plus a t naught, substitute in the v place, we substitute omega r. From this we get mu n by m equal to omega r by t naught. We assume this as equation 1. Okay, in the final situation, it is projected with velocity u along the axis of the cylinder. So we assume this at x-axis. Okay, this x-axis, this as y-axis. All right. So and it also has a angular velocity omega along the tangential direction. So both are acting simultaneously. So the resultant vector is in this side. Okay. So friction always opposes the motion, so it always acts opposite to it. So friction will act this side. So we divide it into two components, f cos theta, f sin theta. So we analyze the motion in x direction. Okay, f cos theta equal to mass into acceleration. So acceleration in the x direction equal to mu n cos theta by m. So in the equation of motion, u square equal to 2a into s. So we have to find here displacement. Okay, so we have to find how far will the ring move along the rod before it stops. Okay, So S equal to u square by 2 into mu n by m cos theta. So we have to find the value of this. Okay. So we have mu n by m value here. So what is the value of cos theta? So for this we had drawn a triangle. So r omega u, the resultant is this. From this cos theta equal to u by root of r omega square plus u square. You can substitute here. So final answer is S equal to ut naught by 2 omega r into omega square r square plus u square. So this is an interesting problem from Pathfinder. Alright, let's continue to the third question. Alright, so the third problem says a disk placed on a large horizontal floor is connected from a vertical cylinder of radius r fixed on the floor with the help of a light inextensible cord of length L as shown. Coefficient of friction between disk and the floor is mu. The disk is given a velocity u parallel to the floor and perpendicular to the cord. How long will the disk slide on the floor before it hits the cylinder? So it is given a velocity u and perpendicular to its length parallel to the floor. So it is happening in the horizontal plane, so nothing of gravity here. So writing free body of it, as the particle rotates by angle d theta, so we have to find the displacement before it hitting the cylinder. Okay, so it rotates by angle d theta, so the arc length is x d theta, so we assume this as x. The length consumed is x. Okay, basically from this x equal to total length minus this arc length r theta, so L minus r theta. Right, so ds equal to x d theta. In the place of x we substitute L minus r theta into d theta. So we integrate it from 0 to L by r. So L by r is total length consumed by it. Okay, from this L equal to L square by 2r. So it is the displacement traveled by the particle before hitting the cylinder. Okay, equation 1. Okay, from friction acts backside, so opposite to it. So acceleration is constant in this case. Okay, so mass into acceleration equal to minus mu mg. So we take in vector direction. Okay, from this acceleration equal to minus mu g. Equation 2. From 1 and 2, s equal to ut plus half at square. We write here equation of motion to find time here. So in the place of s we substitute this ut minus mu g by 2 t square. So it is the quadratic equation in terms of t. You have to solve it. So we get t equal to u by mu g plus minus root of u by mu g whole square minus L square by mu g into r square. So after getting this, the determinant. So if the determinant is greater than 0, so this condition is possible. If the determinant is less than 0, it is not possible. So the particle doesn't hit the cylinder. Okay, alright. If you like the video, do like and do subscribe. Thank you for watching.